Welcome, ladies and gentlemen, to Lesson 7.3. I can find area of composite figures, also known as irregular figures from time to time. Some things you're going to need to know are to make sure that you have the area formulas for all of these figures in your notes, and they're easily accessible to you, and that you know what the parts of each shape are or is. So take a moment to pause and get this down. That would be very helpful to you, and I'll probably look for it in your notes. So, area of composite figure. A composite figure or an irregular figure is made up of two or more shapes. So, examples here would be that this is one big shape. You wouldn't actually see that dotted pink line. And that is one figure made up of a parallelogram and a rectangle. This would be a figure made up of a square and a half of a circle, also known as a semicircle. And this is a shape that's made of a trapezoid, known as two parallel sides, or one set of parallel sides, and a triangle. Essentially, this is our goal today. We are going to find the area of a composite figure by decomposing or breaking up the figure into shapes with areas that we know how to find. Then we will find the sum, or add, those together. Occasionally, sometimes you're asked, and this is shaded figures, which we won't talk too much about, but maybe you're asked to find the area of the shaded part. In that case, we'd be subtracting. So again, here are the formulas that you need to review. It looks like we can't quite see this one. Just like from the other page, except some in words here. So knowing that this is base times height, triangle is half the base times the height. Some of you know this as base times height divided by 2. Same thing. And area of a trapezoid, and area of a circle. One thing you're going to want to keep in mind is half of a circle. So if I was looking for a semicircle, it would be the area of the circle divided by 2, split in half. So, area of a composite figure. So, we see that we are given a shape, and first we have to figure out what two shapes we're given. So I see that I can break it into a semicircle, which again is right here, half pi times radius squared, or divided by 2, and a triangle. So what I need to do first is I need to split this up. I'm going to look for the area of the semicircle, and I'm going to look for the area of the triangle. So the formula I need for the semicircle would be area is 1/2 pi times the radius squared. And for the triangle, area is 1/2 base times height. So I'm going to do one at a time now. I need to make sure I know what my parts are. So I see it looks like that I'm given the diameter, see, this is the full length, the diameter of the semicircle, and I need the radius. So I know that half of the diameter of 6 would be 3. So I know that the radius is 3. And so I can plug that in. So the area then is 1/2 pi radius of 3 squared. So I have the area is 1/2 pi times 9. So generally, again, just in case I'm asked to go in terms of pi, I like to do my constants, my rational numbers, without pi first. So I have 4.5 times pi. And again, if this was in terms of pi, you would leave that as 4.5 pi, and this was meters squared. But if you continue doing that, you do 4.5 times pi, you get that your area is 14.137. Generally, you're going to ask to be round to the tenths, so you're going to get area is approximately 14.1 square meters. And that is, again, we're not done. That's just the semicircle. I want it for the whole shape. So then over here, for my triangle, I see that my base is 11, and the height of the triangle is 6. So I plug in my base of 11 and the height of 6. Multiplication can go in any order, so I'm going to take half of an even number. So I take half of 6, so I can rearrange it just to give you a visual. That's what I did. So I'm taking half of 6, which is 3. So then I have area is 33, which is again meters squared. So then what I do is add these units together. So the area would be 14.1 plus 33. So it's 47.1 square meters approximately, because I rounded with pi. Alright, find the area of each figure here. So you can try this one. I know people have a creative way of doing C. Sometimes people find the area of the rectangle and subtract that tiny little triangle, knowing that this side would be 5 and that side would be 7, but that's up to you. You could split it up like that, making a square and a trapezoid. You could split it up there and make a rectangle and a trapezoid. You have lots of options, okay? So try some of these and do your best. I am going to do A. Okay, so apparently this deleted all of my recording, so I'm going to walk through it because I can't erase it. So make sure you're not just chasing to copy down, but you're listening through the process. Otherwise, it's confusing. So here, we're talking about the plan of a mini golf course, and it's shown, and it's made up of a trapezoid and a parallelogram. Trapezoid being here, parallelogram being here. So I wrote down what I needed. I wrote down the formulas for which each I needed. And then I wrote down the given information from each shape. So I went to the trapezoid first and plugged in all the given information, worked in my parentheses first, multiplied and then multiplied again, found the area of the trapezoid to be 7.5. Went over to my parallelogram, multiplied base times height, got 15. For the composite figure, I added them together, and then since it's a word problem, I gave it meaning and said that 22.5 square feet of turf is needed to cover the area here. So pause on this one, follow through the steps, make sure you know how to get them. Sorry about the tech difficulty. And we can try this one then too. So pause if you want to try it on your own, and then come back. Chloe's father is building a shed. How many square feet of wood are needed to build the back of the shed? So this is a visual of the back of the shed. And I noticed that it's made up of either 3 triangles and a rectangle, or you could just consider that one whole triangle at the top. So I need to split up my shapes, area of the triangle versus area of the rectangle. My formula for a triangle is area equals 1/2 base times height. Area of a rectangle is base times height. For my triangle, I am given a base, which is the same length as the base of the rectangle, so that's 15. I'm given a height of the rectangle, of the triangle, right here, which is 4. So I plug those in. Area is 1/2 base of 15, height of 4. And I can do this in any order, so I'm going to take half of 4 first. So I get area is 2 times 15 for an area of the top of the shed of 30 square feet. For my rectangle then, I know my base is 15, my height is 12. So I plug those in. Area is base times height. So the area here is 180 square feet. So the composite area together will be 30 plus 180, which is equal to 210 square feet. So adding meaning, it would say that Chloe's dad needs, it says needs, 210 square feet of wood for the back of the shed. All right, so again, we did talk about referencing shaded figures. So again, you could see that this shape here is cut from a rectangle. There's 4 triangles that are congruent. Remember, congruent meaning they are the same size and shape. So we could find the area of the shaded region and round to the nearest tenth. So what I could do is find the of the large rectangle, assuming those triangles are there. And that's length times width or base times height. So area is 12 times 5. So the area for that would be 60. And there's area of triangles. Notice there's 4 of them. Since they're congruent, I can find the area of 1 and multiply them. In the area, so there's 4 of them at 1/2 a base of 1 times a height of 1. So the area then would be 4 times 1/2 times 1, which is really just 2 times 1, so an area of 2 for all 4 of those added together. So what that means is it's the rectangle of 60 minus the 2, which is 58. So the area of the shaded part is 60 minus 2, or 58 square inches. Give this one a try and see if you can figure it out. Don't forget that there's a little rectangle down here and a bigger one up there, so you're going to have to find the area of the large rectangle, the shaded part, the whole thing, and then you're going to have to subtract the area of the medium rectangle as well as the area of the smaller rectangle. So whether you add these together first and then subtract is up to you, but you're going to need to do area equals length times width or base times height at least 3 times using different dimensions. So hopefully that glitch wasn't too bad for you. Rewatch what you need to. Check out examples in the book, online, iExcel, etc., etc. See you soon.